Okay, before I show you the inside of the intake, we have the intake off, we're going to check the injector out. I want to cover one thing with you guys that I missed, and I want to make sure that we're all clear on what I'm trying to say. And what reminded me of this is a video that I did with Eric the car guy, which was on an S10 pickup that had an injector problem. We talked about the same kind of scenario where we had a voltage pattern issue, a problem, and I had mentioned it being on the ground wire or whatever, and I didn't mention the feed wire. So what I want to cover with you guys is the feed circuit. I think in our last example I mentioned that our problem was going to be either with our amperage pattern that we had, our problem was going to be either the coil, the wiring, or the driver. You guys remember that, right? I missed something, not in this car. I was correct in what I told you, but depending on the situation, we have a potential to have a feed circuit problem too on this side. Remember what we're doing. We're measuring the amperage here, okay? And there is a splice that we are before the splice that we go to the other injectors. So there's 3 injectors that share the feed. We know that we have 2 working ones. So we know that the feed side is good from here back. No question about it. We wouldn't have a resistance problem on this side because it would affect the other 2. And I guess that's what I'm trying to tell you guys, depending on the situation, is if you were just checking a single injector, if we were just doing one, that we didn't have a tie-in, and you had low amperage measured from the feed side, which is where we are, we could have resistance in front of it, we could have resistance after it. This is both on the feed side, resistance in the coil, resistance on the ground, and resistance in the driver. So it really is all of it. Do you guys understand in our situation where we're measuring that it cannot be in front of this ammeter where we're measuring? We're measuring at that main connector. Maybe a better picture of that is we're at a connector here, and we have all the wires that come through, but the main feed comes through the connector. The intake manifold is right here, so we can't get to anything else. And that splice is underneath. So are we correct in saying we have to pull the manifold from where we are? Were we correct in saying that our driver was fine? The answer is yes. But could there be an issue, say, on our number 3 on the feed circuit right here that is not affecting these other 2? So in other words, at the splice, could we still have a feed circuit resistance problem? And the answer is yes, we could. So I just wanted to cover that in this situation where we were measuring. Remember what I said, are we $700 confident we need an engine computer, or are we confident enough to pull the intake off? And what I said is we're confident enough to pull the intake off, and we were. This doesn't change that, but I just wanted to make sure I'm covering that extra variable on the feed circuit, and why we weren't concerned about it when pulling the manifold was because the other 2 injectors share that same feed. Does that make sense? Okay. There was one other thing I wanted to say. So how would you know, say in this scenario, whether it be the power side, the ground side, the driver we addressed, I think we did that part good. The ground side we addressed. How would you know if you had a voltage drop on the supply side? Well, let's look at this car real quick. Remember, our number 3 injector is the red trace. Our number 5 is the blue. I think it's the number 5. It's a good injector. And let's look at our supply voltage on this. 14.4 is our supply voltage. I'm on the control wire. On the blue trace, 14.3. Same voltage, right? So does that say that our supply side is good? See a lot of heads shaking yes. It doesn't. Here's why. When we are looking at this supply voltage, do you guys understand that the injector is off during this section right here? The circuit is off, okay? With the circuit off, where there's no ground, the driver's off. So if we have 14 volts coming into here, we have 14 volts coming out, the circuit is unloaded. Could we have a resistance problem still in the feed side that we're not seeing? The answer is yes. On the video that me and Eric did, the feed side was so bad that we had a voltage drop in here. We had, if I remember right, we had maybe around 7 volts or so with the circuit off. Now that seems contradictory. It's not. If this feed circuit is so bad, your voltmeter itself, even being a 10 mega ohm impedance meter, now the Pico is 2 mega ohms, so it's less than a regular DMM. Could the meter itself that you connect to that circuit cause the voltage drop if that resistance is high enough? And the answer is yes, and that's what can do that. If your resistance is high enough, you will see a drop here with the circuit off, but it's got to be an extremely high amount. If it's a small amount, the only way that you're going to see that would be to check your voltage supply, okay, with a voltmeter the same time that you are monitoring the injector activity. And when the injector turns on, what you would do, it would look like this. Take this red trace here. Take this line. When is this injector on? The injector is off right here, right? Injector is on down here. When would we want to view that supply side? If we thought our low amperage was from a supply side problem, we would throw in another channel, throw in another measurement, measure your supply side while the injector is on. So that other channel would look like this, and you would want to make sure that you have 14 volts maintained when. We don't care about in here with the injector off. We care about when the injector is on and there is current flow. That's what would identify the supply side problem. There's a lot of variables. I just want to make sure I'm clear in what I'm saying. What we said before was accurate. Intake's got to come off. I don't know where we're going yet. We just pulled the manifold. I just wanted to cover that in case we find a supply side resistance problem, or if we find a ground side resistance problem. I want to make sure we're covering that. Now maybe it's the injector itself. We're about to find out. Okay, last thing. I keep saying that. Last thing. Well, it's not the last thing if I keep going, is it? Another thing. Right? Yeah. Another thing would be, just to be sure we're clear about these voltage drops and what we're talking about. If there's no current flow on a circuit, there's not going to be a voltage drop. Okay? No current flow, no voltage drop. But there's a fine line there. If that resistance from whatever, corroded wire, whatever, is high enough, when you connect your meter to it, the meter causes the voltage drop. It does take a certain amount to, quote, run a voltmeter. Even a digital voltmeter that's 10 mega ohms, or a scope that's 2 mega ohms, will draw something from that circuit in its measurements. That's what causes the drop. If there was some way that you could look inside the wire without connecting anything to it, as long as there was some connectivity, I don't care if it's 1,000,000 ohms of resistance, as long as there's some connectivity, there will be 14 volts in that wire. In our example, 14 volts. As soon as you connect your meter up to it, pulls it right to ground. To us, it might look like 0. Say open circuit. There might be some connectivity. Or you might see 3 volts and the circuit's off. And so then you say to yourself, well, that contradicts what Danner said. He said, no current flow, no voltage drop. And look, the circuit's off and I have 3 volts. Why do you have 3 volts on a 14 volt circuit? Because that resistance is so high that the meter's pulling it to ground. That's an extreme case. In our case, a slight voltage drop, say it's 10, 15 ohms maybe, may not be seen, would not be seen with the injector off. And that was the point in putting our voltage up. At the same time, we would look at our negative side voltage. When the injector is on, whether we look at current or negative side control, we put our positive in there, make sure it stays at 14. So just another variable doing voltage measurements, voltage tests. So some great questions asked of me by my students here, which is, we need the circuit loaded to verify this, and our concern here is this middle injector. This is our number 3. And where the splice is, we're concerned about the feed side, we're concerned about the ground, and now that its intake's off, we can't load the circuit anymore, and that is correct. I mean, we really can't. But then what I'd mentioned is if we disable the ignition, disable the fuel pump, we can, well, did we take the grounds off? No, the grounds are attached to the lower part of the intake. We can still crank the engine over and do injector voltage patterns on both the feed and on the ground and verify what we're talking about. Make sure we have good supply and make sure we have a good ground. Now, we already verified our ground as far as from the connector out, but same thing. In this little section of ground wire, we could have resistance. So there's a lot of different ways to do this. Now, one of the things though, if we crank this engine over, we would definitely want to move these paper towels. And I'm laughing because I have had students do that before and then not tell me that they did that and bolted everything back together, and we had a car with a 3-cylinder misfire. And what it ended up being was paper towels all wrapped around the intake valves. And the car literally had a 3-cylinder misfire, and it took us forever to get the paper towels out of there. So I like the idea of having paper towels here to keep stuff from falling in there, but we certainly don't want someone going in the car and cranking it right now. I think the easiest way to approach this, and I know you guys know how much I love my ohm meter, and I hope you can hear the sarcasm in my voice. The ohm meter can get you in trouble more than any tool there is. Now, there are some times we need the ohm meter. But in any case, I think the easiest test is to ohm the injector coil first. And I think my suggestion is going to be to do that. We'll do a visual on the wires, just a gentle tug. They look okay. The connector's definitely plugged in. We're going to disconnect this and do a resistance check on the injector, and we'll compare it to one of the other two. I think that's the easiest place to go next. Something before I show you the ohm meter, things we look for. If you look on underneath the fuel rail there, you see, looks like pieces of paper towel. It's not. It's some other type of material that was there, and basically what I'm showing you guys is a little mouse or a squirrel nest. It wouldn't be a squirrel, I guess, because it's a pretty small area, but this is what we find, and we find wires that are chewed by little critters. I just wanted to point that out. Not that I'm seeing any wiring damage here, but it's kind of neat to see where animals find their homes sometimes, and when you see that, that definitely makes you suspicious of wiring. So just a thought. Okay, showing the resistance check now, we're going to compare the number 3 in the middle to the number 5, and I'll just kind of keep you zoomed out here. We'll keep you focused on the meter. Got to do the number 3 first. And what we're doing is we're just putting one lead to each. We're making sure that our leads do not touch each other. We're on an auto ranging ohm scale, and what we're reading is 53 ohms of resistance on that middle injector. I think we already know what our problem is. Let's compare that now to the number 5. Typical saturated switch injector is around 12 ohms, 12.5, 12.4 ohms of resistance on that number 5 injector. And we're bouncing around there a little bit. Sometimes that happens when we don't make good connections. There you go, 12.1 ohms of resistance and 53 ohms on our number 3. Okay, that's good, Scott, thank you. 53 ohms of resistance on our injector. I don't think there's any reason to go any further. I mean, we did have evidence of a little mouse, so we'll do a visual inspection. You know, if you guys felt the need to, you could put a Noid light on here, which is made to check injector circuits if you wanted to check that last little section of wiring. But if I do not see any physical damage, I'm not worried about it. It definitely needs a number 3 injector, no question about it. So we'll get an injector, we'll put it in here, see how she goes after that. Doing an ohm measurement of our new injector just to show you guys. And it is 11.4 ohms, and I will show you what this looks like compared to one of the injectors that are already in the car at room temperature. This is the resistance of one of the other injectors that are in the car. This is at room temperature. We're showing around 13 ohms of resistance. So you can see we have a slight variation between the new injector and the injectors that are in this thing, but we're not going to be too concerned about that. I think the final captures are going to be how does the car run, is our misfire gone, and then we'll do our low amp probe test on these fuel injectors one more time and see if we can see nice even ramps across the board. So we got the injector back in on this Nissan now. I have it running already. I want you guys to listen to it. Our misfire is definitely gone. I don't know if any of the other shots we were actually able to catch the sound or not. It's actually been about 4 or 5 days waiting on the part, so you know, this is a little bit difficult for me figuring out where we were and what I showed you so far, but I'll let you listen to it. It's nice and steady, no miss, it revs good, so we definitely fixed our misfire. Let me get you a shot of my connections one more time, and I want to take you back up to the scope screen, show you the after waveforms of the injector, and a couple of variables there that I want to show you too. So I'm at that same connector we were at before. My amp clamp is on the heavy red wire that feeds all of the back 3 injectors. My yellow trace here is my number 5. That would be one of our known good injectors we were looking at before. And then my green channel here is going to be my number 3 injector. Those wire colors, for anyone who cares, the blue, white is number 5, and the red, yellow is the number 3 on this connector. Number 3 is the injector we replaced, so that's going to be our green channel. And again, amp clamp is going to read all 3, and I'm just looking at 2 injectors here. Number 5 as a comparison to what we had before, or an older injector, number 3 being the new injector. Okay, I'm using the Pico again. I have my attenuator set up for channels C and D. That's my 2 injectors. These 2 channels down here, and my blue trace is my amp clamp. I showed you guys these connections before. Focus on the blue trace first of all. We see nice, even, uniform spacings, heights in these injectors. We can drop our time base down, we'll see a little more detail, or what we can do is we can just zoom on that. And in this capture right here, this is all 3 injectors. I'm going to do this a little bit differently. Drop my time base, go to a lower scale here. Focus on this blue trace. We see a couple of characteristics here. One is all 3 injectors are now basically the same amperage. Some slight variations, but that says, oh, I'm on voltage, my fault. That says 106 millivolts. On the setting I'm using, that would be 1 amp. Let me change my channel 1 scales here. I'm using my 60 amp current clamp in the 20 amp mode. And all that did really is change my amperage number there, guys. So that's 1.06 amps where that line is. Some slight variations here, not a big deal. All 3 of those are now firing. If you remember before, our number 3 ramp was very, very low. We do see some different characteristics in the ramp, and I don't like this ripple here. So it's one of the first things that I noticed. Let me turn these other channels off for a minute. So one of the first things we noticed was all these oscillations in here. I'll show you a more zoomed out view. And this isn't necessarily a problem with the car, but you see that ripple. So looking for where that's coming from, and by the way, look, I didn't zero this out very well. I need to re-zero my amp probe. Okay, that's a little better. See that oscillation coming and going there too. What I did is I turned on channel B and I connected channel B right to my battery. This is from the battery itself. So channel B is connected, yep, right to my battery. Where is this oscillation coming from? Charging system. This is right at the battery. We're going to ignore this for this vehicle. It's not causing a running problem. It is an issue. Probably have an alternator that's starting to fail, but that's what this ripple is. Just another variable when it comes to looking at waveforms. And you know, that is affecting our amperage reading here. So move this up out of the way. Focus again on this guy. And you understand all these oscillations in here and why it's all wavy looking. Makes it difficult to see this next part, and that is this pintle hump. This pintle hump location in the ramp, it's actually different from injector to injector, and mainly because we changed one. And I know there's a lot of material out there that talks about location of the pintle hump and it should be X%. You know, what I'm finding is every injector is different and we really can't compare pintle humps. Now, the problem with that though is if you didn't know at a later point in time that this thing had an injector replaced, you might focus too much on that. The reason our pintle hump is in a different location on this vehicle is we have a different injector. So what I can do is I can show you the individual one here, and that would be by pulling in my other channel. So let me turn these other two on. And if I want to look at, remember number 3 is on my green trace, number 5 is on my yellow trace, or this orange trace on here. If I want to look at that ramp only, what I can do is trigger off of one of these other ones. So instead of triggering on channel A, I'm going to trigger on, we'll do the number 3 injector. We'll trigger on channel C, and then I move my trigger point up into an area where that is. And now we're just looking at the number 3 current waveform. Instead of looking at all 3 being drawn over top of each other, we're now looking at the number 3 only. Take note of where that pintle hump is in relation to where it turns on. So beyond halfway. So this is number 3 current, number 3 voltage. Let's take a look at the spike too while we're here. This voltage spike on this number 3 is actually hitting about 100 volts, and that's really why we wanted to use an attenuator. I think if I remember, the old injector was around 52 volts or something like that when we were looking at the voltage waveform. So let's focus now on our number 5 injector, which is our 4th channel. So down here, I'm going to trigger off channel 4. There's my injector voltage waveform. You see the pintle hump. It kind of changed characteristic on us a little bit, didn't it? Let's bounce back and forth. This is number 5 current, number 5 voltage. Number 3 current, number 3 voltage. We see different characteristics in this. The hump is more pronounced. In fact, our voltage spike is different. Look at the height of this voltage spike on the number 5. This is the one that we did not replace. Is 82 volts. Trigger off C. And this one is 99 volts. Now that kind of matches our resistance measurement we did earlier too. We had, I think, 13 ohms of resistance on the factory injectors that were in there. And on this one we had, I think, 11.9 or 11 point something, 11.8 maybe, ohms of resistance. So a little bit more bang maybe, you know, with the magnetic field, a little bit more current. I don't know the current peak of that. Let's get a measurement there. kind of touching that 1.14 amp line there with that one. And yeah, it matches. Our resistance is lower on this new injector. Our current is a little bit higher. Our magnetic field collapse, the spike is higher. Here's the point. It's just a variable changing an aftermarket, using an aftermarket part. And I think it's important to point this out because if you get this vehicle in at a later point in time, let's say you have a misfire, are you going to focus on the fact that one of your 6 injector pintle pumps looks different? Are you going to focus on one of your injector magnetic field collapse spikes looks different? I mean, that's what we do. So it's a variable here, something to think about. This is not causing a problem. The car's running fine. We fixed it. But look at the waveform characteristics. It's a little bit different. So I wanted to show you guys that. One more time, I'll show you that ripple that's going on. Channel B. Turn this guy back on. He is on. Just going to pull him down in here. And we'll look at a little bit more time there. You see this red oscillation from the battery. This is battery voltage. Is exactly corresponding with this blue trace. And so the noise, we can call it noise if you want to, in our injector pattern is caused by something going on with this alternator. Now that's going to need to be corrected. It's not causing a drivability problem in this car. We have seen them where they do. In fact, I'll throw a hyperlink in here for a vehicle with a bad diode and an alternator where we had a speedometer that was going nuts and some crazy stuff like that. I'll throw the link in for that. So we really see the same ripple in our voltage waveform here too. So that's it. Faulty injector on this Nissan. Maybe one more thing I'll show you is our coil current ramps again, because that's another variable. We talked about that before, but we're talking about variables and waveforms. Let's show you one more time. I'm going to move my amp probe to that ground wire that all the coils share. Get a reading on that. First thing we want to do, acquiring a new signal, is we really want no trigger. Never have a trigger set up when you're acquiring a new signal. And we really don't need these other channels. Our coil current is what we're looking at, this blue trace. Increase our time base. These other channels, battery and my injectors, really aren't needed at this point, so we'll just turn those off. That battery ripple, I don't know, we can leave that there. It's not a big deal. Here's your coil current patterns, and again, we see that coil number 3. Why does it look like that? It looks like that because it was replaced. Trigger off A. Get some detail there. This is repetition. We know that's the number 3 from before. We see repeating each time. And if I go in on this, this is all of the coils being drawn over top of each other. And you know, we see different characteristics with that number 3. Zoom back out one more time and show you. Freeze the picture, and that would be this one right here. That characteristic on that number 3 looks a lot different than the coil next to it. The height is different. Why? It's different not because the computer's controlling it any different, but because that is a different coil. It is an aftermarket coil. And again, this vehicle would come in, and you saw this. You have a number 3 cylinder misfire. Now think about this. Number 3 cylinder misfire, let's say down the road it comes back with a number 3. We have a coil on the number 3 that looks different. We have an injector on the number 3 that looks different than the rest of the car. Tell me that wouldn't throw you for a loop. You know, imagine the car comes in with maybe an intake valve problem or something on that number 3. You're going to be possibly changing an injector and changing a coil to no avail because the waveform characteristics look different. So maybe a final word here on this video would be aftermarket parts can affect the waveform. But that's a fix. Number 3 injector was our main issue with this vehicle. I think I'm happy where this is at now.